special and in Iraq generally. Today I will explain chapter 9, electrostatic. Electrostatic. What's the meaning of electrostatic? Electrostatic, it's branch of physics that deals with static charge. I.e. charge at rest. Okay. Charge Q. Okay. Electric charge, it's intrinsic characteristic property of fundamental particles just like mass. Its unit of measurement is coulomb. And it is a scalar quantity. It is formula. Its formula Q equal IT. Remember this law equation you did get in grade 9, okay, for 1 year ago. Q equal Q the charge, I current, and T is time. Okay, for that coulomb equal ampere times second. This charge. Example of charge. Particles. Proton, electron, and alpha particles. This example for charge. particles. Okay. Charge of electron E equal minus 1.6 times 10 power minus 19 coulomb. This electron charge. Charge of proton, same, but is positive, plus 1.6 times 10 power minus 19 coulomb. This proton charge. For neutron, you know, an atom has proton and neutron and electron. Electron is minus charge, sorry, negative charge. Proton positive charge, but neutron is neutral charge, equals 0. The charge of neutron, charge of neutron equal 0 coulomb. Now when I can say the positive and when I can positive and negative object, negative charge for objects. When I can say positive and negative charge. Now I draw these objects. Positive charge and, sorry, I can write 6 positive charge and 5 negative charge. For that, the charge of this object is positive. Why? Because the positive charge more than negative charge. It is positive charge. Okay. I can get total charge by algebra, because the charge is scalar quantity, positive, number of positive, plus number of negative, and get total of charge. Total of charge, this leads to charge of objects. Time. This object has 5 positive charge and 6 negative charge. Okay, 6 negative charge. Which one more than? The negative charge more than positive charge. For that, this object has negative charge. Okay. Last one has equal positive charge and negative charge. 5 positive and negative, 5 negative. For that, the total charge equals 0. Here, 0 charge of objects is neutral object. right node any neutral object will be charged when it leaves or exceeds the electron. Any natural objects will be charged when its like or exceeds the electron. For example, this object has 4 positive charge and 4 negative charge. It's natural objects. Okay, the total charge equals 0. For this charge, these objects to be charged must lay electron or excess electron. For example, when the electron will be positive, okay, when excess electron will be negative. Okay, it's very easy. Okay. If the electron will be positive. If excess electron will be negative. Okay. Okay, now of charge I'm already positive. Negative. Okay. Take properties of charge. Properties of charge. Number 1, charge is quantity. Okay. Charge on body must always exist as integral multiple of fundamental unit of charge E. Hence, Q equal N times E. N is number, E charge, electron charge, electron charge is constant, 1.6 times 10 power minus 19 coulomb, and N is number of electron in any objects. This number. Take example. Calculate the number of electron objects its charge or point or column. This charge of the objects. Okay, here. Very easy. Q, so Q equal NE. Calculate the number. N equal Q over E. Q equal 0.1 over E is 1.6 times 10 power minus 90. 1 times, I can write this number like this, 1 times 10 power, how many? 1, 2, 3, 4, minus 4 over 1.6, 11, equal 0.625 times 10 power. Okay, this go to up, minus 4 plus 19 equal power 15. I can write this number times 10 power 12 electrons. Okay, very easy this equation. Please go back to example and correct this word. Electrons, no electron, electrons, number of electrons. Okay. Okay, like, I mean say, charge, repair between the charges. Unlike, I mean opposite, charge, charges, charge, attract. Okay, this means I have two objects, one positive or negative, same charge as between them repel because the same charge. Also, if I have two positive charges, also repel because it's same. But if I have different charge or opposite charge, get attracts them because opposite. Okay, this number 2. The charge is conserved. In any reaction, the total charge on an isolated system remains constant. This means conserved. For relative invariance, relative invariance. This means the charge on a body doesn't vary, I mean different. This means different. Vary with the speed. This properties mean the Q on rest objects or objects at rest stay same even the object's motion. Okay, don't change the charge with speed. Still same. Q rest equal Q motion. This is number 4. We will take Coulomb law. Okay, this is for French physicist Coulomb law. Okay, it quantifies the amount of force between two stationary liquid trickly charged particles. Okay? According to the law, magnitude of electrostatic force acting between two point charts is directly proportional to product of charts and inversely proportional to square of the distance between them. Inverse square law. Okay, this means I have 2-point charts, positive or negative, of distance between them. Here r distance. Okay. If the charges are same, the force between them is repulsion. But if the charge is different, opposite, positive, negative, or negative, positive, the force will be attraction. Okay, for that, Q here, objects, Q positive, and there, Q positive, the force, repel or repulsion. Force between them. But Q attraction force between them. Okay. Now I will write the Coulomb law mathematically. The first proportion between the force and the charge amount directly. This means F directly proportion with the Q1, Q2. 2. Force inversely proportion with square distance between them. Okay. inverse square law. Hence, if can write if proportion Q1 Q2 over R square. Hence, F equal K Q1 Q2 R square. Okay. Now, K, this column constant. K equal 9 times 10 power 9 Newton times meter square over column or per column square. Okay, and K equal 1 over 4 pi epsilon naught. Okay, epsilon naught is permittivity of vacuum. Permittivity of vacuum E naught equal 8.85 times 10 power 12 column square Newton per Newton meter. Okay, this is for vacuum. Okay, for any medium, write epsilon without not. Okay, there's also constant because it's vacuum. Okay. E H permittivity of medium. Example 1 in your book, a point charge of 2 microcoulomb was placed at 90 centimeter from another positive point charge of 5 microcoulomb. Calculate the mutual force between them and type of the force and reason. Given Q1 equal 2 microcoulomb. Change micro to 2 times 10 power. Micro equal 10 power minus 6. Okay, column. Q2 are positive. Also positive. Microcoulomb equal positive times power 6 minus 6 column. The distance equal 90 centimeter, change to meter, T over 100 equal 0.9 meter. From law, F equal K Q1 Q2 over R square. Okay, this is Q1 Q2 Q1 Q2. Need Q2 need from me to get the force of Q1 will be acting on Q2 and force of Q2 acting on Q1. Yes, okay. F1 on 2 equal Q constant K is constant, is 9 times 10 power 9, Q1 2 times 10 power 6 minus 6, 5 times 10 power minus 6, or R equal 0.9 square. Mathematically, it's very easy. 1.2 equal. Okay. Now I multiple first one the numbers. 9 times 2 times 5 equal 90. 2 times 5, 10. 10 times 9, 90. Times 10 power. 9 minus 6, 3. 3 minus 6, minus 3. Over. Okay, here 0.9 square equal 0 cancel with 1. 9 times minus 2 over times minus 2. Okay, change this to power, cancel this. 181. 9 is equal 1 over 9 Newton. Okay, this F1 over 2. Okay, this was what's the difference between force 1 on 2 and force 2 on 1? Just opposite, just direction. The magnitude is same. Okay, here I can write F21 equal F12. Okay, according to magnitude, I mean magnitude is equal, but the direction is opposite. For that, I must write minus. F21 equal, what's the mean this? This means the forces are same magnitude but opposite direction. Okay. Okay. The type of force is repulsion. Why? Because of the charges of same type. Positive, two positive. Positive charges. Okay. Next lesson, we will answer more question about or more problems about common law. Here, the end the lesson. Remember, stay home, stay safe. I wish you to be well. Good luck. Bye.